Hello, everyone. Welcome to our webinar, Choosing the Right EV Chargers for School Bus Fleets. Our expert speakers today are Markos Mylonas from Entegrity Energy Partners, Alison Wiley, the creator of the Electric School Bus newsletter, and Taylor Sayward from the Mobility House. They're going to discuss charger selection, bus depot design, and other insights from their deep experience in fleet electrification. We're excited to share real-world examples and best practices to help you navigate the future of your school's fleet electrification. We're going to begin with a short poll, and then Alison Wiley, the creator of the Electric School Bus newsletter, is going to start. Let me just show you really quickly our agenda for today. So this is the order of speakers. And then if you have any questions along the way, you can submit them in the chat with a question mark at the end, and it will go into our Q&A.
I'm Alison Wiley, and I'm the creator of the Electric School Bus newsletter. And I'm excited to be here with my colleagues from Mobility House and Entegrity. I'm in the beautiful state of Oregon. We come from different places. I'm on the ancestral homelands of the Chinook and Multnomah peoples. And I've been writing the Electric School Bus newsletter since 2019, before they were a thing and before there was federal money for them. And we all know that under the new administration, federal funding for electric school buses and other things will probably shrink. But I do expect electric school buses to keep growing. And I think that funding would have shrunk in any event because they need to be sustainable and the savings that they generate need to be funneled back into the whole capital purchase cost. So when Taylor and Markos and I met earlier this month to organize this webinar, I volunteered to go first because what I specialize in is overviews, including of charging. And I'm a communicator and I curate complex information. And chargers can be complex. My speaking and my writing is designed to save people time because people are busy and they need the bottom lines on things. So I'm at electricschoolbus.org and I do consulting as well as writing and general networking and putting people together. So what I'll do before Taylor and Markos go on with their deeper dives, I'm going to give you basic high-level things you need to know about chargers. And I'll let you know, I don't have a fleet of my own. I like having this fake background because yellow school buses are so cool. But what I do is I talk a lot with the people who run the school bus fleets, and I rely on them for my on-the-ground information. And so I'm going to give you some big picture things and some basics on chargers, some vocabulary and types. I'm going to talk for maybe 10 minutes. My favorite part of any webinar, whether I'm on the panel or an attendee, is the Q&A at the end, because that's where I feel like we're really communicating and finding out what people are really needing to know. So I'm going to launch with some big picture. In the US and its territories, there's about 13,500 school districts, and there's almost 500,000 yellow school buses. That's a lot. And so some good news, and it's WRI who just keeps track of this, about 5,000 on the road are now electric. That is so much growth in just a few years. Other news is that 99% of the school buses are still fossil fueled, largely diesel, some propane, and some gas. So what we take away from all of this, friends, is that most school bus fleets are new to electric, most. And I always keep that in mind when I write and when I speak. Also, I don't pressure any fleet or person to move to electric. People have enough pressure in their lives, and there's already larger forces in play that are moving toward electric regardless. So I let people move at their pace. I supply information and support as needed and as people are interested. Let's talk about some basics around chargers. Vocabulary can be really valuable. I'll give you some tips on deciding what type of chargers to use based on my conversations with people who are using chargers. And then I'm just going to give you two general principles to use as you're dealing with chargers. So when Taylor and Markos and I met earlier to plan this webinar, we decided that we're not going to be covering vehicle to grid, V to G, V to X. It's interesting. All of us are interested in that. Pilots are happening in different parts of the country, but it's beyond the scope of this webinar. And so we're not going to be fielding questions on V to G, as interesting as it is. Chargers by themselves are a big enough topic for 1 hour, believe us. Okay. Chargers are harder than electric school buses. They're less intuitive. None of us grew up with chargers. And so we have to learn all these things. Plan to spend more time when you're dealing with chargers than with your electric school bus. It takes a lot of time to choose them and then to break the ground and implement them, deal with your utility. Let's talk about how chargers are measured in their size. It's about kilowatts, abbreviated as kW. That's the power of the charger. It's kind of like the width of a fire hose. How much juice does it deliver? Is it more of a trickle or is it more of a blast? 19 kilowatts is kind of typical for level 2. We'll do more on that, and my colleagues will talk more about that too. Electric school buses, they get measured not in kilowatts, but in kilowatt hours, kWh. And think of those as a unit of energy, like a gallon of diesel gas. So two different measurements. Your chargers, they come in kilowatt sizes. Okay, the big topic with chargers is typically, what level do you need? Do you need level 2? Do you need level 3? So level 2 is also known as AC, alternating current. L2, level 2 is easier to talk about. The bigger, more expensive, more brawny, beefy, direct fast chargers, we'll call them level 3. Level 2 and level 3 is a little more intuitive than AC or DC. What you will not hear anyone talk about is level 1, because that's just a really small trickle. And that's what you and I are using right now for our computers. So chargers are all about level 2 and level 3. Okay. How do you choose a charging provider? Here's the best advice that I've gotten from some of the most experienced transportation directors. You've got to figure out whether your brand of bus, your OEM, Lion, Bluebird, Thomas Built, IC, Green Power, your bus and your charger have to be able to talk to each other. And so you want to find out if you have your brand of bus picked, let's say that it's, I don't know, Lion. Find out from them what chargers are working for you on the ground. If you know that you're wanting to work with OpConnect or with ABB, ask them, what brands of bus are you working with in the field? And ask for references. You want to know about the existing customers, because that electronic handshake is not always the easiest thing to navigate. Not every charger works with every bus. Conversations. You want to see proven results. Theory is different from practice. You want to know what particular chargers are working in different fleets with that particular brand of bus. Thomas Built is the only brand of bus that I'm aware of that will only do level 3, and they will only take Proterra chargers. So that's unusual. That's kind of an outlier. It's something to keep in mind. One transportation director says that he likes for all of his chargers to be from the same company. Not all feel like that. You need to know what the maximum charging rate of your bus is. And that's a different thing than battery size. These things are fairly technical. I'm going to skip on down and talk a little bit. I'm going to get to portable chargers before I hand off to Taylor. But one transportation director says that choosing your charging equipment, choosing your charger and ordering it, that's the easy part. And his experience is that the hard part is getting the utility ready to receive and accommodate your charging purchase. Okay. Keep in mind that the electric grids nationwide are old. They're old and they're not necessarily ready for some of the bigger, faster charging situations. Keep in mind you have a choice between pedestal chargers, they're going to take up space, and then there's wall chargers, which take up much less space. You're going to make choices between these. ballards. If you have pedestal chargers, you're going to need these posts, these ballards around them to keep your buses from accidentally running into them. It takes up more space. So you're going to be planning in your bus yard. Sometimes you'll have to reconfigure your bus yard in order to make space for your chargers. I'm going to talk for just 1 or 2 more minutes. Some utilities that you're going to work with will give you a list of recommended chargers that they feel more comfortable with. There might be a protocol. Also, your chargers, you might need them to be collecting data. Sometimes your funders might prefer a certain kind of charger, or your funder might want to be collecting data on how the chargers are used, how much uptime. So planning and permitting. And then finally, I'm going to say that charge management software might sometimes be a better investment than level 3 chargers. Level 3 chargers cost a whole lot more than level 2 chargers because they charge fast, maybe a few hours. Your level 2s, it's overnight charging. And that works for most routes. So, and I'm getting a message that my internet connection is unstable, and I'm really sorry about that. Can't control that very well. Portable chargers are another option, and they cost less, and they are something that's up and coming. So keep in mind that portable chargers can be valuable. Okay, 2 principles. As you're doing your electrification journey, you want to talk with your peers. You want to tap into the many school bus fleets that are already electrifying. Usually the people there, they want to talk with you. There's monthly meetings in the Pacific Northwest. We have a monthly meeting. You want their advice. You want to know what's working on the ground. And before I hand off to Taylor, I'm going to share something that I got from one of my colleagues that I interviewed when I was preparing for this panel. She's got more than a decade of experience working with chargers. She noted that there are some tell the truth cultures within businesses and with our general work life. Being candid, saying when something isn't working, maybe your product needs more work. The tell the truth culture is what we want to be cultivating. Some cultures are not so much about telling the truth, just wanting things to be simple or look good when they're really not good. Talk about the problems, when we run into them. Let's do critical thinking. Let's all build a strong tell the truth culture as we work not just with chargers, but as we electrify and deal with clean energy in general. Okay, that was kind of fast and dirty. I look forward to questions. I'm going to turn over to Taylor.
Huge thank you to Alison. I think this whole industry and all of us are far better off with folks like you out there disseminating good information and keeping the industry honest and informing people of all the things they need to know. Everything you just named are, it's still not even all of the key considerations for this transition and choosing hardware that works for your fleet and get your school district's needs met. The list goes on. So hopefully we'll get to touch on a few more today. I'll give myself a quick intro too. For those of you who don't know the Mobility House, we are primarily a technology provider of charging and energy management system, like Alison spoke to just briefly. Right, our technology controls and manages chargers, right? So we have, and is one of our core values is that system is sort of charger agnostic. So we have a wealth of experience working with charger OEMs up and down the industry in school bus fleets and other fleet use cases. So we also sell chargers when it projects call for that. But I think our kind of authority to speak to this topic really comes from our experience managing lots of different hardware out there and different use cases, and having these conversations with folks on the ground as to what chargers do I need, right? This is a big question and a complicated one to answer with so many products out there on the market. Again, the purpose of today and my bit of this webinar is really to highlight a few of those key considerations for this decision around which chargers to procure, which products make the most sense for your school bus fleet use case. And in the interest of making sure we're all on the same page and understand what some of the terminology we're using is. I want to sort of lead with just a few definitions to make sure that those of you who are not so familiar with electricity and some of the other technical details of the products and things that we're talking about, that we're sort of on the same page and we can give just a little bit of education where it's necessary. So Alison touched on this before, right? But chargers generally, not generally, they are measured in kilowatts, right? That is a measurement of power. This is right, the rate of charge that a charger will give. The flip side, right? Alison said this too, that bus batteries are measured in kilowatt hours. That is a measurement of energy or the amount of energy that lives in that battery. I think for the purposes of this thought experiment of which chargers make the most sense, I wanted to propose a hypothetical that hopefully resonates with a lot of the school bus folks out there. You know, some familiar territory with new units and new terminology, I think. I'll risk doing a little bit of math in public, but here's a hypothetical to sort of consider. A school bus that does, you know, a morning and afternoon route, 50 miles each. So 50 miles in the morning from 6 to 9 a.m., another 50 miles in the afternoon from 3 to 6 p.m. You'll see lots of very simplified numbers, but all very plausible numbers given the industry we're in and the stuff we're talking about. So if this is a helpful sort of timeline to understand what I just said about that duty cycle, right? A morning route from 6 a.m. to 9 a.m., likewise a 3-hour block in the afternoon. Otherwise, that vehicle will be sitting around at the bus yard, able to charge. Now, in the interest of sort of familiar territory, let's take a hypothetical bus that maybe used to have a 60-gallon tank for diesel fuel and maybe got in the ballpark of 10 miles to the gallon, right? Probably numbers that lots of you are very familiar with from operations of old, right? Now, without introducing too much too soon, now with EVs, we're going to start thinking instead of gallons in a tank about kilowatt hours to a battery. So for this hypothetical, let's think of a 200 kilowatt hour battery. Again, a simple number for the sake of this hypothetical, but very plausible. This is sort of right there in the ballpark of the products that exist in the market. And on the efficiency side, now instead of miles to the gallon, we're thinking about kilowatt hours per mile. So again, a simple number, but 2 kilowatt hours per mile is a simple but very plausible, if maybe on the conservative side for vehicle efficiency of an EV school bus. Right, so those are things that we can assume for this hypothetical. And now the question is, okay, great. With that, given that duty cycle, given this vehicle, what charger do I need? And this is hopefully just to illustrate sort of a thought experiment that you can run when you're thinking about your school bus electrification project to get you in the ballpark, or at least a starting place to what chargers make sense. So let's run with this hypothetical. At 6 a.m., the vehicle has been charging ostensibly overnight, and when at 6 a.m. we'll be at 100% state of charge. And now you've got a 50-mile route to run with a sort of known efficiency of the vehicle. So that would be some simple math here, 50 miles, right, times that efficiency number, 2 kilowatt hours per mile. That will land you with an understanding that morning bus route will use about 100 kilowatt hours of energy to get the job done, right? And if you remember the size of our battery on the bus, that is about half of the battery pack. So when you return to home base at 9 a.m., that vehicle will be at 50% state of charge. Now you have the next 6 hours, right, from 9 a.m. until the afternoon block at 3 o'clock to charge that vehicle. And this window is really important, especially midday window, all right, we refer to as the vehicle's dwell time. So you have 6 hours, and to get back to 100%, you need to fill back up, let's say 100 kilowatt hours of energy on the battery side. So last and final math problem for the day, right, would be to take that 100 kilowatt hour need on the battery side, divided by the dwell time, that 6 hour window, would give you around about 16.5 kilowatts, right? Charging at that rate would fill the bus battery back to 100% by 3 o'clock, right? This would get the job done in the afternoon as well, right? Now, there's a lot of other considerations besides this, right? The price of electricity in the middle of the day might be higher. So there's certainly cases where you may not want to charge for 6 hours straight, and you may not need to get back to 100% state of charge for the afternoon block. But again, for the sake of a sort of conservative, bare minimum place to start when you're thinking about charger needs, this simple equation is a good starting place, right? That charging need in kilowatt hours divided by the dwell time, right? Which is just the number of hours that you have to charge, right? This math is probably less important overnight because there's 12 hours in this case, right, to charge the vehicle back. It's this midday block that for a lot of school bus folks is really important to think about. So again, this is just a starting place. There is a lot of other things to consider. And I think also best guidance always is to, if you land on a sort of ballpark figure like this, to always be conservative, right? 16.5 kilowatts, that is a very common sort of level 2 or AC charger power level. Again, so I would take that as sort of a bare minimum place to start when thinking about how to get your needs met on the charger selection side. Okay, so now that we have a power level in mind, or at least a ballpark, Alison touched on this too, but one of the key ways that chargers are categorized is by AC versus DC power. And again, in the interest of educating anybody who's not super familiar with those terms, AC means alternating current. This is what happens on the electrical grid all around us. DC stands for direct current. This is the energy flowing, the power flowing inside of a bus battery, right? No matter what kind of charger you have, at some point, a conversion from that AC power on the grid to DC power on the bus battery side will happen. That conversion happens somewhere. This is the big distinction between the sort of technical capability of these two different types of equipment. So let me talk about AC chargers first. Alison mentioned this before too, but colloquially known as level 2 chargers, right? An AC charger, that conversion from AC to DC power happens on the vehicle side, in fact. So there's a piece of equipment on the vehicle itself, on the school bus, that facilitates that conversion from AC power to DC power. That means that an AC charger, by definition, is much simpler electrically and across the board cheaper, not only to purchase, but also cheaper and sort of simpler on the installation side as well. Also, not completely hard and fast rule, but in general, right, AC chargers are lower power than the DC counterparts, and that equals slower charging, right? In a lot of cases for school buses, not too slow, but again, there's, depending on what your needs are, AC chargers may or may not be a good fit. The flip side of this, of course, is DC chargers, right? Also sometimes known as level 3 or DC fast chargers. I've heard these terms interchangeable all the time. Here, that AC to DC power conversion happens at the charging station, right? That means, this is what facilitates that equipment being able to charge a vehicle at much higher speeds because they can convert straight to DC power and plug that right into the bus battery. But again, by definition, that means that this equipment, DC chargers, they are electrically much more sophisticated, complex, and expensive, kind of across the board. And there's a huge range of DC chargers, but sort of any way you slice it, they are, again, more complex, more expensive on the equipment side, and even in some ways the installation side as well. And again, higher power means faster charging. I pulled this graphic from the white paper, the resource that I mentioned before, but I hope this helps to illustrate sort of the difference between the two and where these types of products fall on this continuum of power level, right? So if power level is increasing as I go further right here on the screen, AC chargers, they live in this sort of 0 to 20. In truth, it's about 19.2 kilowatt level. That's kind of where AC chargers max out. There's a reason for that. I don't need to go into it right now. And on the flip side, DC chargers, they range from sort of 15 to well over 120 kilowatts. There are 300 and 400 and 500 kilowatt DC chargers out there that are far more than what any school bus fleet would need for a variety of reasons. So this sort of optimal zone that we're flagging here for school bus fleets in the sort of 15 to 60 kilowatt ballpark. Again, this is a high level sort of ballpark range, but based on the traditional kind of daily route duty cycle of a school bus, this is typically what we see as a really good fit for school bus fleets. So I think helpful to sort of narrow the range of options that make good sense for school bus fleets. So again, that's kind of a range that hopefully helps narrow down your charger selection journey. And last point on this that I think I want to call out is that this range, I want to clarify that this means kind of per port, right? So each school bus needs about this much, depending on exact needs. But I'm certainly not saying that a 120 kilowatt charger is not a good fit for school buses, because in many cases, 120 kilowatt DC charger will come as a dual port configuration, meaning there's two charging cables, both capable of giving 60 kilowatts to each bus. So again, this kind of optimal range here, I mean to clarify that and say it's kind of a good range to consider per port or per vehicle. Hopefully that's helpful. The last consideration that I want to flag before I pass things over to Markos is charger compatibility. And again, Alison touched on this too. But there's several ways that chargers are compatible or incompatible with other parts of your sort of fleet charging ecosystem. Really important to consider. And the last kind of electrical term here that I want to introduce for those of you who are less familiar with it is voltage, right? So electricity is delivered at different voltages, and all of the equipment we're talking about has both input and output voltages, and they must be compatible in order to work, especially on the facility or the site side. And I'll describe what I mean by that right now. So in the United States, common electrical services at your facility or anybody's facility will be either in 208, 240, or 480 volts, right? The electrical service, the electric panel at your site will be in one of these voltages. And again, each charger has an input voltage that is specific and required to be compatible with installation on any given service. For the most part, not a hard and fast rule, but many of your kind of existing electrical systems at the school district or a bus garage and so on will probably fall into the 208 or 240 volt range. Sometimes if there's more heavy duty equipment or big lighting projects and so on, 480 volts is not, it's less common, but it does exist. And then for sure, if the utility is bringing you a new dedicated service for EV charging, it will almost certainly be a 480 volt electrical service. So AC chargers, kind of across the board, are input voltage at 208 or 240 volts. So very important to know. DC chargers, on the flip side, generally have an input voltage of 480 volts. There are a couple products out there, a couple of DC chargers that in fact have an input voltage option of 208 or 240, meaning that there are only a couple of DC chargers out there that you could successfully install on a 208 or 240 volt panel, which is really important to know if you're, just deploying one or two chargers and you're not getting a new service brought in, but you're instead just installing equipment on the existing site electrical service. Then, of course, there's vehicle compatibility. And there's just a couple of things I want to flag here. Interoperability testing is sort of the gold standard of understanding, hey, does this equipment really work with my vehicle? All the vehicle and charger OEMs are doing this, but it's always good to check with your bus dealer, your partners, your vendors to know if those tests have really been performed successfully, if there's proven compatibility in the field. Alison noted this as well, but every make and model of vehicle has a maximum accepted charge rate, right? Every bus OEM has a different maximum accepted charge rate, meaning they may, if you have a 100 kilowatt DC charger and plug it into a vehicle, it may not actually be able to charge that vehicle at 100 kilowatts. The vehicle may sort of max out at 70, 80, 90 kilowatts instead. So it may not be necessary to go too large. And then, of course, Allison mentioned this too. Not every make or model of vehicle and school bus can accept AC chargers, period. To date, Thomas Built has been the big OEM in this that falls into this category. And I've heard this may change in the future, but again, I'm not here to represent Thomas Built. But I've heard that may change, but also still very good to know if you drive Thomas buses. Last thing on this compatibility piece before I hand things over is compatibility with a charge management system, right? Just two important things to flag here. That your chargers that you're purchasing sort of speak this industry standard protocol called Open Charge Point Protocol, or OCPP. This is an open standard across the industry that most charger OEMs are zeroing in on, but there are some products out there whose chargers sort of use proprietary communication protocols, and so they're not always compatible with other charge management systems. So good to know, because you may find yourself in a situation with a mixed fleet of chargers and the need for separate software systems to manage and control them, which is just less than ideal from a sort of future-proofing perspective. Lastly, the connection between chargers and charge management softwares can be enabled via Wi-Fi or cellular signals through the cloud, and or via Ethernet cable, which is far and away more reliable because it's just a hard connection. But just to understand that various chargers out there on the market are enabled and have different means of communication with charge management systems, and to know that the ones you're purchasing, for example, maybe have an Ethernet cable port, and so on. The key takeaway here is to check the specifications of your vehicles, your chargers, about compatibility, and ask your partners and vendors to confirm whether all of these interoperability tests have truly been met, if there are, cases in the field of successful deployments of all the equipment and vehicles that you're talking about.
Hi, everybody. Thank you, Sam, for the introduction, and Allison and Taylor for your presentations. It's a pleasure to be here sharing this stage with both of you. Again, my name is Markos Mylonas. I'm an engineer for Entegrity Energy Partners. I'm personally based out of our main offices in Little Rock, Arkansas, but we have regional offices and operate in the South Central region of the US. Beyond school bus fleets, we have more than a decade of experience working with school districts in our footprint on all kinds of sustainability projects. So how do we at Entegrity arrive at our charger selection recommendations for our clients? Well, we start by asking questions to identify your needs. And when I say your, I'm referring to the student transportation directors or departments. So what does your current fleet look like? What routes does that fleet run? What does your site look like? Are there any unique challenges specific to your needs? This allows us to arrive at a charging solution that you can be confident in for the long run. So let's dive right in. So starting off with the basics, performing a full assessment of your current fleet. A lot of the transportation directors in the audience will probably know this information by heart. The goal of this step is to quantify your short-term and long-term transportation needs. Start by comparing your total fleet size versus the number of routes. Define your own versus lease vehicles and your route versus trip buses. Focus on district-owned route buses first. To help further narrow down your candidate list, filter or score your current vehicles for quantitative features like age, mileage, fuel efficiency, operating costs, maintenance costs, both preventative and unplanned, overall condition and reliability, dealer support, etc. Any obviously problematic vehicles make their way to the top of the list here. For example, vehicles that will require costly repair or even replacement in the near future. Note that if federal or state funding is used to electrify your fleet, there will be additional conditions to be met by the qualifying vehicles. For example, age limitations and requirements for the vehicles to have been on the road transporting students in the past year. Finally, you end up with a range of candidates ranked from most important to least important, representing your short-term versus long-term vehicle replacement needs. Moving on to the route assessment phase, the goal of this step is to identify which of your current routes are suitable for electrification. As mentioned before, current EV buses have an advertised range of about 120 to 150 miles per charge. We recommend setting a 100-mile daily maximum, that is AM and PM routes combined. This allows for some safety margin in situations where extreme temperature or driver behavior is affecting the efficiency, in addition to allowing the buses to operate within a healthier state of charge window of within 20% and 80 to 90%. Choosing routes around the 100-mile mark will optimize your fuel savings. More miles electrified equals more fuel dollars saved. However, at this phase, continue to consider the full range of route lengths, from shorter daily routes up to that 100-mile maximum, as your charging options might be limited due to utility or site constraints. Also consider your end users, i.e. your drivers. If there is anxiety caused by this new technology, you could start your electrification adoption with shorter routes and work up to the longer ones as your staff gets more comfortable. In addition to ranking your current EV routes by length, consider the route topography. EVs are better for inner city routes with lots of start stops and idling, and not so much for long highway miles or rural routes. Consider the route duration of both the morning and afternoon routes. Mapping out this schedule will allow you to identify overnight and midday charging windows that will help answer the question, how fast and when would the buses need to charge? Furthermore, consider your current route management practices. Are you using telematics? What are your current route tracking needs and challenges? Also think of your future goals. How are your routes expected to change in the future? For example, will more routes be added due to a growing student population? After identifying your fleet needs, so the range of buses to electrify, and your route needs, how many routes are eligible to electrify and how long they are, move on to identify your site limitations. Choosing where to locate your charging stations will be heavily influenced by overall ease of access and the utility power availability. Start with identifying your current utility service. Where is the meter and panel located? And is there space for any additional load? Also consider, what else does the service serve? Are there other areas of future expansion that might make more sense to utilize this additional capacity instead, i.e. building expansions or new depot lighting? Unless you're only adding 1 or 2 level 2 chargers, in most cases, the existing utility service will not be enough and a new service will be needed. In this case, coordinate with your utility engineer on what options you have regarding the new service location. The distance between the new utility meter and your charger should be kept to a minimum to keep installation costs down. Also discuss the limitations of the new service and any available tariffs for each type and service considered. Are there time of use or demand charges, for example? The conversation with your utility should include current versus future needs. Ask the question, can this new service easily accommodate your long-term goals? Beyond the power availability, additional questions to consider are, what is the overall yard condition? Is it gravel or asphalt? What are areas to stay away from? Maybe due to difficult access, close to stormwater drains, or prone to collecting water after heavy rains. What does the overall topography look like? When selecting the preferred area, consider, is there enough space for the EV supply equipment, the transformer, switchboard, feeder panels, etc.? Is there enough space for easy access to the chargers and protective bollards? Furthermore, will your vehicles park forwards or backwards? This is very important to determine, as charging port location needs to be specified before purchasing the new buses. EVs might require wider parking stalls than diesel vehicles to provide access to the charger cable port, typically located on the front or rear passenger side of the bus. Is the area well lit? Drivers might need to access the chargers and buses in dark conditions. Consider site security. Are there vandalism deterrents needed? For example, adequate fencing, security lighting, or cameras. Lastly, consider overall equipment protection. Is the site located away from any potential hazards? Also consider potential ADA requirements as needed. Finally, the last and arguably most important step before selecting your EV chargers is selecting your EV buses. At this stage, we've already identified our fleet needs, our route needs, and explored our site capabilities and limitations. In many cases, the vehicle selection can be done before everything else is considered, but the same questions would still need to be asked to ensure an optimal selection. So reach out to all school bus dealers in your area and collect vehicle submittals. What manufacturer do they feature? What battery sizes are available? What is the advertised range? What types of charging is accepted by the vehicles? What is the maximum charging capacity accepted? What is the vehicle and battery warranty offered? Discuss how and where your new vehicles will be serviced. If the buses will be serviced by the dealer, is their location within EV range of your depot? Remember, 100-mile daily miles is recommended. If your preferred dealer happens to be located further away, how are they planning on performing the service? Do they plan on coming to your depot with a mobile mechanic? Would a flatbed trailer need to be utilized? And what are the added cost implications for that case? Beyond the logistics, how excited are your potential new partners about school bus electrification? Have they already trained or are in the process of training their own mechanics to provide full support to your new EVs? Do they have their own chargers installed at their location? How knowledgeable are they, and have they worked with other school districts in your area? Discuss training and workforce development. What training opportunities for both your drivers and technicians are available through the dealer? Do those opportunities meet your short-term and long-term needs? Lastly, do you have a strong working relationship with them? Is there trust in place? Regardless of the product, customer service is key. How will they support you when things go wrong? So thank you all for listening, and apologies for the rapid fire of questions that I sent your way over the last 10 minutes. I'm hoping I have touched on some items that will be useful in your electrification journey. I hope that you're one step closer to choosing the right EV chargers for your school bus fleets, and I look forward to your questions and to connecting with you in the future. My email and phone number is listed on the slides if you'd like to chat more. Thank you.
Thank you, Markos. I think with the time we have left, we're going to try to answer some questions. So I'll pull up the Q&A. We'll start with this one. Is anyone aware of the comprehensive list of EV charging products manufacturers that currently meet the BABA, is that a Buy America compliance as required by the federal funding grant?
I can speak for a moment. I see Alison, thinking about this as well. Not to dodge the question, I'm not sure. I'm not aware of a comprehensive list that's out there that says here are all the charger OEMs that make such products. I just for those who may not know exactly what that BABA stands for, right? The Buy America compliance effectively means chargers that are the majority of components are sourced or assembled here domestically. It's a requirement of spending EPA dollars, namely, but others probably state level funding programs. This is a question that's come up for us with a lot of school districts that we work with, and it's always been a conversation with various EVSE partners or charger manufacturers, whether they produce chargers or particular charger models. In the US is kind of a case-by-case thing. There very well could be or should be a more comprehensive
I don't
list.
have an answer for that. I'll just be honest. I don't have an answer for any list of Buy America.
Good question, though, and for sure worth flagging that it's an important one to meet those requirements. And general guidance otherwise is that those that do, when they're manufactured here domestically, they tend to be more expensive because that usually means those manufacturers shifting production to the United States when before it was happening elsewhere. So in general, we've seen a higher cost of those chargers, which, you know,
Something to add here from my experience, guys, is don't ask when you ask that question to your manufacturer, ask for the specific product that you would like to use and see if that's manufactured in the US, because a lot of the manufacturers only will or have plans to manufacture the consumer-based, the more consumer-focused products here in the US, so that they have a wider range of markets they sell those chargers to. So make sure that the charger that you're interested in is scheduled or is already being manufactured in the US, not the brand overall.
Yeah, I know that a lot of those charger OEMs have prioritized much higher powered DC charger for public charging use cases, for example, in the US first. So
we had a question that came in earlier. Was if anyone could provide examples or successful solutions to charging electric school buses in cases where the drivers take them home during lunch overnight, and being able to drive them, to and from work.
So I researched that question, and a very helpful person got back to me, and I posted that. The drive home scenario is really popular, especially in rural districts where there's long distances. And the answer that I got from an experienced person was that not necessarily going to work unless you have a really big battery and you don't need midday charging. I'll just pitch in that directly below me in my garage, we have a level 2 charger because we have 2 electric vehicles, not Teslas. They happen to be Nissan Leaf and a Chevy Volt. So a level 2 charger, is very doable at home. Not super expensive. So I'm just kind of putting that out there because some people are open to having a level 2 charger in their garage. It's just a thought.
it speaks a little bit to the voltage compatibility or other compatibility points that I mentioned before, right? That to install a charger that would fit a school bus use case well at somebody's residential single family home, for example, it may be possible for a level 2 if that's what will work for the fleet, but in other cases, it may not be electrically possible for some of those.
It would need a lot of vetting.
Right.
It would be a case by case basis.
Sure. Yeah.
I need to mention something that a transportation director had shared with me, and it corresponds with CMS, charge management software. There's been real cases where you can, instead of getting the expensive level 3 chargers, you can get software that spreads out your use of level 2 chargers and can save you money. And software, unlike a physical charger, like behind me, you're seeing pedestals, charging management software can get updated. It can change with the times, which a general physical charger cannot. So charging management software is something to consider.
I would be remiss coming from the mobility house not to jump on there and say absolutely what you just said is right. And just to reiterate too that the software solutions can do the same types of optimization and so on for DC chargers as well. It's not limited to level 2s, but
especially if you have capacity constraints. If you don't have a large amount of electricity at your site, then software is especially valuable. I know a large fleet with a lot of electric school buses, they have a whole lot of electrical capacity and load available to them. They don't choose to use software. So, a lot of this is case by case.
Hopefully this was some timely information and education for those who needed it. I also, in the chat, I did see a note from somebody who I believe really knows what they're talking about, that just to clarify that Thomas built buses can in fact accept other DC chargers besides Proterra chargers. Things have been evolving. I can attest to.
I appreciate that correction.
Yeah.
In the audience, there's always a wide bandwidth of knowledge. It's not just the presenters who know things. Everyone in the audience generally knows some key things too. Of
course.
Well, thank you, everybody. This has been recorded. We will distribute it to everybody who's just signed up. So even if someone didn't attend, they will still get the recording. If you attended, you'll get the recording. And just thank you so much for everybody's time. I hope you have a lovely rest of your afternoon.
Thank you, everybody. Thank you, Markos and Allison, too.
Thank you guys for
Pleasure.
setting it up.